Hello, and thank you for attending this short presentation from Keysight on doing power analysis. Today we're going to demonstrate a M.2 disk drive plugged into a PC here, and we're going to integrate the analysis of the PCIe protocol on the protocol analyzer along with the power usage captured from one of our oscilloscopes. We're going to integrate all that information together and look at a single power analysis profile of this M.2 drive. For doing this analysis, we are using the U4301B M.2 PCIe interposer that connects to our protocol analyzer. That interposer has the connection points for our M.2 drive and connecting to the system under test. Also on this interposer are connection points for a power analysis and also connecting to some of the other signals. We have a 50 milliohm resistor that allows us to use the N2820A current probe with our oscilloscope to measure the power used on this system. Now, to demonstrate how this is all connected, I have the probe points on my interposer connected to my 2820A current probe going into the oscilloscope. The key thing I have to do on the oscilloscope is set my probe resistance value. So I select probe. It's already determined that I'm connected to the current probe. I just need to select the probe and make sure my resistance value is set to 50 milliohms. Additionally, I have to set up, I'm using the trigger in from my protocol analyzer to control the data I want to capture, and also the Ethernet connection from my protocol analyzer to the oscilloscope so I can control the scope and load the data back to my controlling system. So now we'll go through the setup of the protocol analyzer. After I've launched the software, first thing I need to do is under setup, I select I want to add an external scope. When I select that, it walks me through the connection process. I put in the IP address of my oscilloscope, select that the logic analyzer is going to trigger the oscilloscope. There's my selection. I click Next. Default calibration is great. It reminds me what my connection parameters are for operation here, and then I click Finish. Now what we'll see is it immediately adds the oscilloscope to my overview of the system here. So if I go back to that overview tab, I now see the protocol analyzer and the oscilloscope integrated together. Now I want to add a connection to the waveform, so to make sure the waveform gets the protocol data into that configuration. So now when I go to my waveform in here, I can see the oscilloscope, channel 1, along with the PCIe up and downstream data. Now if I start a capture on here, first thing I need to set up the protocol analyzer itself, which is some parameters of what interposer I'm using. In my case, I'm using the U4301A M.2 in a by 4 link width configuration. And there is a connection diagram here that will show me exactly how it gets wired up for those operations. I select OK, and then I can control my buffer size. How much data do I want to capture? And I click set that size, in this case 256 meg. Click OK. I want to set up a trigger condition, which I want to trigger on the link coming up. So I'll trigger on any TLP packet. Simple trigger capability. Click OK. And now when I hit run, it automatically sets up and it's waiting for the oscilloscope and the whole process to begin. So now I can power on my target system and I will get a capture of the data. Turn on my target. You will see the system's trigger and the data gets returned to my system here. Thank you for spending this time to look at power analysis using the Keysight protocol analyzer and an oscilloscope that allows you to integrate the information for the various PCIe power states and power usage of devices under test. We thank you for spending this time. For more information, look at Keysight.com.